Well, thank you for asking me all these questions. But before I get into what is genetic disorder, I'd like to get into what is genetics in general. Well, genetic is the human makeup. It's what makes us humans in general. It's what makes us look from the outside, the way we look, and the way we function from the inside. It decides upon our hair color, our eye color, how tall, short, fat, skinny. All of these things are decided upon by genetics. Also decides upon our interior function, how big our heart is going to be, our pulse, our heart rate, our blood pressure. All of these things are decided upon by their genetics. Not only that, but there is also sicknesses that are decided by genetics. For example, diabetes, we got stroke, we got heart attacks. All of these things are part of genetic disorders, and they're part of our genetics. Now, when we get into genetic diseases, we look at genetics that have a problem with them. So we got a gene, and then we got an issue with that gene, a problem with that gene. And that is what genetic disorder clearly is. Now, when we look at causes of this genetic disorder, there are 5 main causes that we know of up to the date. And the first cause is by background of family history, we call it. Family history is the history of your family, basically. So whether what your grandparents have, what your aunts, uncles have, that all affects on your gene and your offspring gene. So whether your grandparents have high blood pressure, they've had diabetes, they've had all of these factors influence your genes and your offspring's genes. Now, the second factor that we know of today is how close your parents are. So if your parents are close relatives, for example, cousins, or maybe close cousins or second, third generation cousins, all of these have a factor in affecting how well your genes are, or certain gene illnesses or diseases. And the reason behind that is that us humans are very unique. We are all different, nobody's the same. But when we have genes that are similar, or even in certain cases the same, we don't have the ability to function properly. And that is why when we have 2 cousins, for example, marrying, there's a large chance, there's a huge chance that certain codes are going to be, if not exactly the same, very similar. And this is where we get the trouble and the percentage or chance that the offspring is going to have certain genetic illnesses. Now, the third factor that we know of is if the parents have a genetic disorder. And this seems very clear. If your parents, for example, have a genetic disorder of diabetes, then obviously their offspring or their child has a chance of getting diabetes. And that most people understand. Now, the thing that most people misunderstand or don't really get is that even if your parent does not have an apparent genetic disorder, so it doesn't show up, they don't appear to have diabetes. So they go and they check your blood pressure, it doesn't have diabetes. Yet, their gene codes for it. So you have a gene, but that gene is not active, it's not running to make you get that sickness. But there's a chance that their offspring, their kids, are going to get it. Because again, you're sending all the messages. Not all of them are going to make up you human, but some of them. So there's a chance that you're going to get that portion which says you have diabetes. And lastly, what I want to mention is X-rays and UV radiation. These things are one of the largest factors, not for necessarily genetic disorder, for genetic mutations. And what genetic mutations are is a change in the genes during one's lifetime. So now I could be standing right now and there could be a change in my gene. So the gene changes somehow. Something is pulled, some code is pulled out and some other code is brought in. Or codes are flipped around. Or something is just put out and they rejoin together. All of these things can happen. Randomly, not even, it doesn't have to be necessarily variation, but UV radiation just increases that risk. And by UV radiation, I mean, for example, sunlight. Certain sunlight, if you're not wearing protective gear, if you don't have sunscreen on, if you don't have a hat on, all of these have an effect on your genetic mutation or changing genes. Also, X-rays. If you get tons and tons of x-rays on daily basis, that also increases your chance or your risk of getting a genetic mutation. And genetic mutations, we can't always say that they're always negative. The majority is negative, usually negative. However, there are some positive aspects to them. For example, we look at sickle cell anemia, which is a disease we mainly see in Africa and other poor countries which have malaria. And malaria is a very, very deadly disease. And what we noticed is that the body, there's a mutation in the gene that protects the person with that mutation, with that mutation from getting the malaria. And in a majority of cases, saves that person's life. However, see, this is the positive aspect of getting a mutation. In the same sense, sickle cell anemia changes the shape of your blood cells and makes you carry less oxygen. Again, this has a big impact on the human body. Every blood cell in the human body usually carries around 4 hemoglobins. Hemoglobins are irons that carry oxygen. So when the cell changes shapes and becomes skinnier or smaller, it doesn't have the capability of carrying that many oxygens. So then we have an issue where the body is not receiving enough oxygen, and usually the person that has sickle cell anemia needs a bone transplant, a bone marrow transplant. So again, there's positives and negatives to it. And I hope you guys benefited from my talk, and hope you gained some valuable information. Thank you for inviting me.